Your starter activity is to look at these keywords. Use them to construct 2 sentences about what we learned about encryption. First of all, what is encryption? What is symmetric encryption? And what's asymmetric encryption? Here are our keywords. What are the 2 types of encryption? Pause the video and try and write those words down now. Hopefully you've selected symmetric and asymmetric encryption. Question 2 is, how do we agree the method of encryption? This is called our handshake protocol. In today's lesson, we're going to be looking at the different uses of hashing. Pause the video now and read the summary. Make sure you have a good understanding of the different types of compression. You also should have a knowledge of the 2 types of encoding, which have been covered in a previous lesson. Again, pause the video and read through these definitions. Last lesson we looked at encryption. Pause the video, make sure you have a clear understanding of these different types of encryption. Please read this article and consider the following questions. What's the difference between hashing and encryption, and why is hashing important? So as we know at the moment, passwords are fundamental to most websites. Sometimes they are being replaced by biometrics. But obviously, anywhere which is storing users' passwords, there's an element of danger to this. So why not encrypt? Well, as we've learned, encryption is a 2-way process. You can encrypt it and then decrypt it. There's obviously a security issue with the key exchange. Hashing is actually a 1-way process. Once the data has been changed and hashed, it's impossible to actually get it back. This is useful for storing encrypted pins or passwords so they can't be read. We'll have a look at hashing algorithms later on in the course. So hashing works that we apply this algorithm to a data value which is stored. When a user types in their password in future, it uses the same hashing algorithm, and it's compared to the stored value. So no organisation actually ever needs to store passwords in plain text. So this is a huge security risk which has been fixed. Now, we sometimes refer to hashing as a checksum. A hash total is a mathematical value which is calculated from an unencrypted message data. The process, remember, is irreversible and it's impossible to crack unless you try every single possible input until a match is actually found. So due to what we call the hash total being generated by the entire message, even one slight change will have a huge consequence. Here you can see 2 hash functions at work, and the total differences and how it creates a massive difference in the checksum value. So in summary, hashing is a 1-way process only used for pins and passwords to ensure that actual plain text is never stored at the server. Once the plain text has been converted, it can be never changed back. When you enter a pin or a password, the same algorithm is applied and the hash values are compared. Your first task is I want you to research digital signatures and digital certificates. How do these apply an additional level of security? Once you've completed this task, you have 4 options. The first option is to use further reading to find out about encryption topics that you've not learnt about. Number 2, research Bletchley Park. What role did they play in stopping World War II? And the ethical dilemma when they actually cracked the enigma. And then finally, using Python. Can you create your own Caesar cipher?